Okay, so welcome back. And we are defining these trigonometric functions of real numbers in terms of that arc length t. And so it will be really helpful for us to look at the domain and range of each of these trigonometric functions and get some idea of the definition of them. So when we say y equals sine of t, now we're saying, all right, we've got this function of t. F of t is equal to sine of t. How do we treat this as a function? Well, one of the things that we have to know is what is the domain and range of this function. In other words, what kind of values can I put in? What kind of values can I get out? Well, let's not forget what we were talking about before. So on a unit circle has a radius of 1, and so every x and y coordinate point on this circle is defined in terms of the sine and the cosine in this specific manner. The coordinate point on our unit circle, x and y, is equal to the cosine of t in place of the x coordinate and the sine of t in place of the y coordinate. So we think about, well, what kind of values can I put in for that arc length t? Well, the answer is that because we could take coterminal angles of any angle from 0 to however large we want, right? As long as we can find that coterminal angle, we're good. And so in this function, it turns out that our domain is any real number at all. We can substitute in any positive or negative real number. The real challenge here is, well, what do we get out? What is our range? Well, our range is the set of all of the y values on our wrapping function that we could possibly get. And we might ask, well, then what's the largest and what is the smallest? And those correspond to these coordinate points. Right here at 0, 1, when the angle or the arc length is pi over 2 on the unit circle. And right here at 0, negative 1, when the angle, aka arc length, is at 3 pi over 2. Right? So our domain, our range is set by the 1 and negative 1 right here. So we're going to say our range is the set from negative 1 to positive 1. That is, the largest sine t value that I can get out is positive 1, and the smallest value for sine of t I can get out is negative 1. Cosine's kind of similar. For cosine, if my function is cosine of t, then t could, again, be any real number. So anything from negative to positive infinity is a good match for the cosine function. But on the other hand, we found that y, well, the value of the cosine of t would be limited by its largest and smallest values. And we found that at 0 right here, at the point 1, 0, the largest x value that I'm going to get is positive 1. At the smallest x value I'm going to get out over here at pi is equivalent to negative 1, 0. And so just like with our previous function right here, it turns out that the range for cosine will also be from negative 1 to positive 1, right? Now, again, don't associate this y with the y coordinate on our circle. We're saying that this y is the value of the cosine of t. So cosine of t, in effect, what we're saying, is limited to giving us values whose numbers are between negative 1 and positive 1. So as you look at this range right here, do keep that in mind. All right, how about tangent? Well, this one's a little bit different, but if we look at tangent here, y equals tangent of t, how do we find it? Tangent of t, we're defining to be, from our unit circle, the ratio of y over x. So this is okay, except at any values where x is equal to 0. So where have we got zeros right here? Well, x equals 0, our coordinate right here, at these top and bottom of our unit circles right here. Right? So we're thinking angles like, well, pi over 2, or 3 pi over 2. If we kept on going, we might say at 5 pi over 2. Or if we went in the negative direction, we might have said negative pi over 2. So what we're saying is that, well, t cannot be equal to these angles because that's where the function's undefined. So what would we say right here? Well, it turns out that we say that our domain for t is the set of all real numbers such that t is not equal to odd multiples odd multiples of pi over 2. This is the way I'm going to state it for right now. We'll come back and we'll redefine that slightly differently later on, right? The y value, it turns out in this case, turns out to be any real number. So in effect, we can get all kinds of numbers out. It's just that we can't put all kinds of numbers in. All right, so let's look at some of these other functions right here. How about cosecant? Well, cosecant, remember, cosecant of t on our unit circle is defined as being y 1 over the y values that we get. So kind of like uh, we find values where y is equal to 0, that's what we have to look out for right here. We see that that happens at 0, at pi, right? So we say, well, y does not equal 0 in this case, and that occurs at values like 0, pi. It would happen at 2 pi again. It would happen at 3 pi, and so on. So as far as the domain of this one is concerned, we could use the set of all t values such that t is not equal to some whole number multiple of pi. So we can just say multiples of pi, integer multiples of pi. Right? And as far as the values for y, well, y is going to be anything that is outside of negative 1 and 1, right? Since we're taking reciprocal of y, right? We would say, well, okay, anything from negative infinity to negative 1 works, but so does anything from 1 to positive infinity. And again, we'll study these a little bit more in depth as we go. Secant turns out is very, very close in definition to the tangent. Why? Because, well, if you think about tangent, it's something over x. This is 1 over x. Right? So we would be looking to eliminate values where x is equal to 0, and that occurs at any odd multiples of pi over 2 as well. Odd multiples of pi over 2. So we would eliminate those from our domain, and we'd say, well, all right, t is in the set of all real numbers such that t does not equal some odd multiple of pi. Sorry, some odd multiple of pi over 2. Its range is kind of similar to what happens with cosecant. In this case, the y values go everywhere from negative infinity to negative 1. Don't include anything between negative 1 and positive 1, and then go from y to infinity. Again, we'll develop this a little bit later on. Finally, one more to describe, and this is the cotangent function. The cotangent function is defined as y over x. And so just like the one above it right here, sorry, x over y, just like the one above it here for cosecant, y cannot equal 0, and that would have to be at any values where we get 0 in the denominator, and those are at these integer multiples of pi, right? So 0, pi, 2 pi, 3 pi, and so on. So for our domain right here, we'd say, well, t, we could use the set of all real values t such that t is not equal to an integer multiple of pi. So we would develop that way, and we'll develop this a little bit further on down the line. The y values are very similar to those of tangent, however, and in this case, y could be any real number from negative to positive infinity. Okay, so we'll come back and maybe use those later.